Here's the real-time solution, assuming we know the right takeaways. Plugging in p equals 5 yields 5 over 100 cubed, which is 125 divided by 1000000. Since 1 million has exactly 6 zeros, the decimal expansion includes 6 decimal places ending in 125. So 0.000125. There are only 3 zeros here between the decimal point and this first minimal non-zero digit. Therefore, p will have to be slightly smaller than 5. The correct answer choice is D. Let's elaborate. This decimal expansion phrasing is not only rare, but includes the added complication of an uncommon which of the following is the greatest possible value. If we didn't know how to handle the question, we should have plugged in convenient numbers, specifically here 1, 2, etc. This approach also solves the question, albeit significantly more slowly. If we know the right takeaways, we need to bear in mind that since the question is asking us about the greatest possible value, it makes more sense to start with the larger rather than the smaller numbers. Let me explain. If, for example, we plug in p equals 1 and it turns out that 1 is a possible value for p, we may still have 4 additional plugins before we reach the correct answer choice. If, however, we plug in p equals 5 and it turns out that 5 is a possible value for p, then since 5 is the greatest possible value appearing in the answer choices, it would immediately have to be the correct answer choice. It's a very simple, reasonable takeaway, yet the vast majority of examinees are completely unaware of it, which is phenomenal news for us. That is why during the real-time solution, we started by plugging in 5. If p equals 5, then p over 100 is 5 over 100. In the vast majority of situations, we would reduce this to 1 over 20. Here, however, the question requires a decimal presentation, so it makes sense to leave the 5 over 100 as is. Now we are required to raise this expression to the power of 3. Remember that the power belongs to both the numerator and denominator. It is highly recommended that you memorize these common powers by heart. 5 cubed is 125, 100 cubed is 100 times itself, 3 times, which yields 1 followed by 6 zeros, so 1 million. Alternatively, we can also say that 100 cubed is 10 squared to the power of 3, which yields 10 to the 6. Remember that the number of zeros is identical to the 10's power. Either way, this expression yields 125 divided by 1 million. And here's a useful little takeaway. Very few examinees know that if the denominator is a power of 10 which contains n zeros, the decimal expansion will contain exactly n decimal places. For example, 1 over 100 is 100th. In decimal form, it is 0.01. You see, these 2 zeros translate into these 2 decimal places. Similarly, when dealing with 125 divided by 1 million, since 1 million includes exactly 6 zeros, the decimal expansion will contain exactly 6 decimal places. Moreover, you can see in this very useful example that the decimal expansion will end with the numerator 125. If we combine all of these pieces of information, we can see that if p equals 5, then the decimal expansion is 0.000125. However, please note that the question required that there be more than 3 zeros between the decimal point and the first non-zero digit. 0.000125 has exactly 3 zeros between the decimal point and the first non-zero digit, which is 1. Therefore, p cannot be 5 and answer choice E is eliminated. I'm reminding you that since we were asked for the greatest possible value of p, and we started with the greatest possible value from the answer choices, we will now need to plug in the second greatest possible value, which is of course 4. Once we know these takeaways, this question becomes far easier. If p equals 4, then 4 over 100 cubed yields 64 divided by 1 million. It's sufficient to see that 64 no longer occupies 3 decimal places, as did 125. 64 has only 2 digits, whereas 125 has 3 digits. This means that 64 will recede 1 decimal place to the right, a decimal place which will be filled with 0. If you didn't see it, by all means, let's demonstrate. The decimal expansion of 64 over 1 million will include, again, exactly 6 decimal places, since 1 million includes exactly 6 zeros and will end with 64. The result is 0.000064. As you can see, there are more than 3 zeros between the decimal point and the first non-zero digit, which is, in this case, 6. Therefore, the greatest possible value for the integer p is 4, and the correct answer choice is D. Just for the sake of practice, let's indicate the decimal expansions for the other answer choices. Answer choice A, 1 over 100 cubed, yields 1 millionth, which translates to 0.000001 zeros. Answer choice B, 2 over 100 cubed, yields 8 over 1 million, which translates to 0.000008 zeros. Answer choice C, 3 over 100 cubed yields 27 over 1 million, which translates to 0.000027, which is 4 zeros. Though you are highly unlikely to see the same exact question on your test, these takeaways do tend to show up every now and then, so please review this video before taking the test.